And those are the probabilities. What am I talking about? I'm sorry. I'm computing covariance. This is variance. Okay, we just want to do the variance on just the stock fund. Get rid of this. Y'all gotta catch me on things like that. That squared. That's the deviation from the mean for the stock fund. And then you do the same thing for the bond fund. I went and jumped ahead and did the covariance. Okay, so here's the deviations from the expected return from the stock fund. And then you square them, you got these numbers right here. And then multiply each times its probability, and that gives you that. Add those up, that gives you the variance. And then if you want to get the standard deviation, you just take the square root of the variance. Okay, you do the same thing for the bond fund. Take its rates of return minus the expected return. Remember, the expected return of the bond fund is 5%. Square that deviation, multiply them times these probabilities, add them up, gives you variance on the bond fund. Take the square root, that gives you the standard deviation. Okay, now we're going to combine them in a portfolio. Any questions on that first? We're getting the variance. Okay, suppose we put 40% of our assets in the stock fund and 60% in the bond fund. So let's see what happens. Okay, this is going to be our rate of return. We had 40, 60. Remember, this is like what I just showed you on the security analysis project when I did 10% stock, 10% the stock, 90% the bond. And here what we've got, we're computing the combined rate of return on a combined portfolio that has 40% in the stock and 60% in the bond fund. And that gives you these rates of returns, right? Rates of return right here. Okay, so you take each of the probabilities, multiply it times the outcome, add them up, gives you expected return on that portfolio of 7%. Okay, then to compute the variance and the standard deviation of that portfolio, you go through this exercise and you get variance 44.26, standard deviation 6.65. Okay, so now let's compare that, the expected return on this portfolio and the standard deviation on this portfolio with the stock fund by itself and the bond fund by itself. Okay, so the stock fund by itself has 18 standard deviation, bond fund by itself 8, and remember the expected returns were 10 and 5 respectively. Okay, so here we've got 7 and 6.65. So we've got a lower expected return on the combined portfolio than we do for the stocks, but higher for the bonds. And we've got a volatility or standard deviation that's lower than either one. And that is the result of diversifying our portfolio. Instead of just buying stocks or just buying bonds, we got both. So the expected variance and standard deviation of that portfolio are less than those of either fund alone. And the reason why is this: the two funds have a negative covariance and correlation of their returns. The risk of a portfolio of two or more stocks or whatever type of assets has risk that depends on the covariance between the returns of the assets. Okay, so we went 6.65. We took So we took one asset, had a standard deviation of 18, the other had 8, and we combined them and we got a standard deviation of 6.65. So that combined return has, and you can see that one dominates that bond fund, not the stock fund, but it dominates the bond fund using the mean variance criteria, because this one has a higher return than the bond fund, 7% versus 5%, and has a lower standard deviation than the bond fund, 6.65 versus, what was that, 8.27. So it's better in both respects. That's something, you know, I know a number of people who will not put one dime into stocks. They say they're risky. But here's the fallacy in that argument. Stocks are indeed risky, but they can actually hedge your other investments, including, you know, it's not just hedging investments, it can include stuff like the salary you get from your job. It could include stuff like the value of your house, you know, stuff like that. They can hedge those too. So it can actually decrease your risk in at least some respects. There isn't anyone, no one on this planet that isn't exposed to risk. Okay, so how we compute the covariance, this is what I started to write up on the board a minute ago. Covariance between returns on the stock, return on the bond. You take the deviation from the mean of the stock fund, deviation from the mean of the bond fund, multiply those together times the probability of each scenario, and you add them up over the scenarios, that gives you the covariance. So here is covariance. Here are the deviations from the mean for the stock fund and the bond fund. Multiply those times each other and also times the probability. That gives you this column over here. Add them up, that gives you the covariance. The stock fund and the bond fund have a covariance of -74. It's difficult to interpret a covariance, but what we do know is if the covariance is less than 0, then they tend to move in opposite directions. It doesn't really tell us how often they do, though. If the covariance is equal to 0, then they ignore each other. If the covariance is greater than 0, then they tend to move in the same direction, although not necessarily always at the same time. So since that one's kind of hard to interpret, we compute the correlation coefficient. We take the covariance between the returns on two assets and divide that by the standard deviation of the returns of the stock funds times the standard deviation of the returns of the bond fund. Now this correlation coefficient is going to have a number, it's a dimensionless number that will range from -1 to +1. So you know if you compute a correlation and it's less than -1 or it's greater than +1, you know you've done something wrong. So the correlation, we denote this with that's a lowercase Greek letter rho. This is between -1, including -1, and +1. Okay, so if you've got rho equals 1, you've got perfect positive correlation. What that means is when the return on one asset goes up, the return on the other asset goes up. When the return on one asset goes down, the return on the other asset goes down. They always move up and down together. Doesn't mean they're equal. They don't have to be equal. They just always, when one goes up, the other goes up, always. When that happens, we say those two assets are redundant. You just pick the one that has the higher expected return and ignore the other one, because buying the other one would not give you any diversification value. Okay, if rho is greater than 0 but less than 1, we say it has positive correlation. In this case, the two returns tend to go up and down together, but the amount depends on how far above 0 it is. If rho is like 0.98, then there's not going to be much advantage to using one to diversify the other. Or the term is actually using one to hedge the other. But if this is significantly below 1, then you've got some value there's some value in diversifying, buying both of those. If rho is equal to 0, we say the two assets are uncorrelated. They ignore each other. That's an even better diversification than positive correlation. If rho is less than 0 but greater than -1, we say they are negatively correlated. And that means when one of the assets goes up, the other one tends to go down, but not necessarily all the time. And that's an even better. This is an even better diversification move than that, which is better than that. And if rho is equal to -1, we've got perfect inverse correlation. And you're not going to see many of those, although it's easy enough to construct one. All you've got to do is short a stock. You own a stock and you short the stock, too. Those are going to have perfect inverse correlation. Or you own a stock and you buy a put option. That'll do the same thing. Okay. Any questions on that so far? So we got the covariance was -74.8, and then we divided that by standard deviation of the stock returns on the stock fund times standard deviation of returns on the bond fund, and that gives us a correlation coefficient of -0.49. And that is a very good, in that case, that's a very good diversifier. And you can see why, because of that diversified portfolio gave us, it dominates the bond fund, but not the stock fund, dominates the bond fund in terms of both mean and variance. It is difficult to find, this example is just a made-up scenario analysis. It is actually quite difficult to find assets that will give you a negative correlation. But if you can find one, great. You generally have to buy stuff like gold, silver, stuff like that. Gold mining stocks. Those are the kind of things that might give you that kind of, you really need a negative diversification, the kind of things that might give you that. Okay. Any questions on that so far? Okay, asset allocation with two risky assets, or asset allocation is just talking about how are we going to allocate our assets in our portfolio, and we're not so much, we're looking at broad classes, we're not so much looking at individual stocks. Okay, so the portfolio risk and return depend on the mean and variance of each security's returns and also the covariance. So how do we estimate the three statistics? One way is to use historical data. The variability and covariability of stocks tend to change slowly over time. And that's true about most financial assets. Their volatility and covariance with other assets tend to follow arch processes. You don't have to worry too much about what arch means. But basically what happens is like this. It will you're looking at the volatility of the returns on some stock over time. So this is time. And here is the standard deviation of returns on some stock or some portfolio. And what it'll do, if you've got real high volatility, it'll tend to persevere. And then it might eventually die down, something like that. If you got real low volatility, that'll tend to persevere. And then sometimes you might get another shock to the system and get real high volatility again for a long time like that. That's why they say that those change slowly over time. So you can, take the realized returns and use that to make your estimate of what's going to happen in the future. And it's not going to be perfect, but it's useful. And that's usually more precise than trying to think up some scenario analysis. Unfortunately, mean returns cannot be as precisely estimated from past returns. You need a really long history of data to estimate mean returns accurately. And it's tough to do that when you're talking about, well, okay, look at the smartphone industry. How long has that been around? Since when did the iPhone came out? What, 07? Yeah, you just don't have much, you don't have much to go by. And there have been some companies like Apple and Samsung that have done quite well, and there's some others like Nokia that are out of the business, or who else? Let's see. BlackBerry, where are they now? Have y'all got a BlackBerry? If I'd asked that about 6 years ago, probably about half of y'all in here would have had a BlackBerry. I had one for about 3 years. So there's just not enough history to go by. It's hard to estimate what's going to be the mean return. It's just not a mature industry. And, Apple's done great, Samsung's done great, but who knows what's going to happen next. Okay. Weighted average return on components. This is a rate of return. We talked about that. The weight on the bond fund times return on the bonds. Weight on the stock fund times return on the stocks. Expected rate of return. Just take the expected value of the returns on the bonds, returns on the stocks. That gives you the expected return on your portfolio. Okay, to compute the variance of a portfolio, what you got to do is you got to take the weight on the bond times the standard deviation on the bond, square that, weight on the stock times standard deviation on the stock, square that, plus 2 times weight on the bond fund times standard deviation on the bond fund, weight on the stock fund times standard deviation on the stock fund, times rho sub BS, that's the correlation between the returns on the bond fund and the stock fund. Now notice this. If that correlation is 0, then all you got is that. If this correlation is positive, it's going to add to that. If the correlation is negative, it's going to subtract from that, so it's going to lower the variance of your whole portfolio. Okay. All right, we'll get into the investment opportunity set. We'll see y'all Monday.